So we are going to go through and do your corrections for the 2-1 and 2-4 quiz, starting with question 1. Remember, at any point, if you need more help, please come see me in 7th period. It says, graph the linear equation using a table. That is a t-table. If you lost any points on this, it's because you didn't make a table. If you remember in class, I told you to make 5 x values. You can choose your own, but you need to have some positives, some negatives, always have 0 in your table. The trick when you have fractions as your slope is to choose x values that are multiples of that denominator. So our denominator in question 1 is 2. That's the bottom part of your fraction. A multiple is, well, the numbers that you can multiply. Here I'm going to start with -4. If I need negatives, -2. I always have an x value of 0. Positive multiples are 2 and 4. When you're plugging this in, you're plugging each value into this equation to get your y's. So plugging in -4, that is y equals 1/2 times -4, and eventually we will subtract 3. Remember, when you multiply fractions, make everything a fraction. You can multiply the tops and multiply the bottoms, or you can cross-reduce. Typically that's what I like to do, but a lot of you make more mistakes that way, so I'm not going to show that, on this one at least. Here, if I multiply the tops, I'm going to say 1 times -4, that's -4 over 2 times 1 is 2, still minusing 3. Doing this division gives me -2 minus 3, which is -5. Plugging in the x value of -2, you have 1/2 times -2 minus 3. I'm going to show cross-reducing here. I can't do much with the 1s. The 1s stay the same, but the 2s I can divide a common number. I can divide 2 from both of them. This gives me 1 times -2, which is -2. For 2 times 1 is +2. Still subtract 3. -2 divided by 2 is -1. Minus 3 is -4. Plugging in 0, that is 1/2 times 0, then subtract 3. Anything times 0 is always 0. So it's 0 minus 3, which is -3. I'm going to scroll down. Plugging in 2 into my equation, I have 1/2 times +2, then subtract 3. Again, you can cross-reduce. 2's have, well, 2 in common, so I'm going to divide diagonally by 2. So this is 1 times 2 is 2. 2 times 1 is 2. Still subtracting 3. 2 divided by 2 is 1. Minus 3 is -2. I'm going to scroll up, put that in my table. Plugging in my last x value of 4, 1/2 times +4 over 1, then subtract 3. I'll go back to multiplying tops and bottoms. So 1 times 4 is 4. 2 times 1 is 2. Still subtract 3. 4 divided by 2 is 2. 2 minus 3 is -1. This gives me enough x values that I could plot and have a pretty good idea of what my graph is going to look like. So 4 is over here. 4, -1, put dot. 2, -2. 0, -3. -2, -4 is about right here. Now, -4, -5. Well, -4 is right here. -5 is down here, so I can kind of estimate, do my best here. You should be using your straight edge, maybe your rulers, and connect your points. So this is what your graph should look like for question 1. Question 2. Then you have a fraction. Same directions, graphing using a table. My denominator in the slope is a 4, and so I'm going to choose x values that are multiples of 4. Make it easy. Here, this is going to give us some big values, but that's okay. So I'm going to choose -8, -4, 0, +4, and +8. Now with these x values of 8 and -8, I will not end up graphing those just because I don't want to extend my graph, because I'll probably make a mistake with my spacing and I don't want to do that. But I should be able to graph the others. Same idea here. We're still going to plug in all these numbers. to our equation to find the y's. And so I'm going to have, again, y equals, plugging in -8. Careful, I have this negative out here. It makes a difference. I'm going to attach that negative to be with my 4 to make my division look a little bit nicer. So I'm going to say -8 over -4, then add 1. 2 negatives when dividing turns positive, so really it's 8 divided by 4, which is 2. 2 plus 1 is 3. Plugging in the next one, I'm going to have -4. Again, I'm going to let that negative be with my denominator. I have -4 over -4 plus 1. 2 negatives make a positive. 4 divided by 4 is 1. 1 plus 1 is 2. You might be wondering why I chose to put that negative with the 4. You could have attached it to the x. I chose to attach it to the constant because I see more people make mistakes when they attach it to the variable and forget that that means -1 times x. So when you attach it to your constant, it makes it a little bit easier not to make that mistake. Plugging in 0, I have 0 over -4 plus 1. If 0 is on top of your fraction, it all turns to 0. If it's on the bottom, you can't do it. 0 plus 1 is 1. Plugging in 4, I have 4 over -4, then add 1. A positive divided by a negative is going to be a negative. 4 divided by 4 is 1. -1 plus 1 is 0. Last one, 8 over -4, then we're going to add 1. Positive divided by a negative is again negative. 8 divided by 4 is 2. -2 plus 1 is -1. So here I'm actually going to plot what I can. Remember what I said at the beginning, I can't plot these 8s. My graph is too small for that. That's okay. We're still just going to plot what we can. -4, or -4 comma +2. -4 is right here, up 2, stop, draw a point. 0, 1, 4, 0. And again, the 8 would be over here, and then our -8 would be way over here. We're going to play a little connecty dots. Do your best with your straight edge, and roughly hopefully your graph looks a little bit nicer than mine. Hopefully your points go into your line goes through your points a little bit nicer than mine. But there you go. Questions 1 and 2. Moving on, question 3 and 4. And it says find the slope of the line. So I'm going to show the formula, and I'm going to show the triangle method, which is a review from last year. I'm going to start with the triangle method. First of all, question 3. If I read my line or look at my line from left to right like I'm reading a book, my line is going up, which means my slope will be positive. So I'm just going to start with slope equals. Same thing with number 4, slope equals. So I know it's going to be positive. So I'm actually going to start at the lower point. If I'm doing the triangle method, from that point, I'm going to rise and I'm going to run. So you could choose a different point. You could have chosen other points that are on this line, but I'm just going to choose the ones that are given. To do my slope, I count how many boxes I rose. So it's 1, 2, 3, 4 boxes over how many I run, which is 1, 2, 3, 4, 5. So my slope is 4 over 5. I'm actually going to check my work by using the formula that we learned in class, which is y2 minus y1 all over x2 minus x1. Remember, it does not matter which points you choose to be your first one and your second. So I'm just going to choose my 5, 3 to be my first point, x1, y1, and 0, -1 to be x2, y2. If I plug that in and I do some simplifying, I will get the same answers. Remember, I like to say with the glasses, keeps everything organized. Make sure you don't lose any negative signs. Your glasses, you got your bridges as your minus signs. Here's my glasses. So here, y2 is -1, I'm going to put that in glasses, minus y1 is +3, I'm going to put that in glasses, over x2 is 0, I'm going to put that in different color glasses, minus your x1 is 5. Then simplifying, -1 minus a 3. I'm getting more negative. That gives me -4 over 0 minus 5 is -5. Simplifying this, 2 negatives when dividing make positives, and I'm left with 4 over 5. I can't simplify more than that. But that's your slope. Question 4, same idea. You can use the triangle method, and then I'll also show you the formula. Reading left to right, this is actually a negative slope, so I'm going to fall, and then I'm going to run. So I'm going to start at the highest point because I fall first. And I'm drawing my triangle to count, and then I run. So I fell. Because I fall, I say it's a negative. Negative 2 boxes I fell. And I ran 1, 2, 3, 4, 5, 6 boxes. So starting with my slope, I'm going to do the fall over run, which is negative 2 over 6. But you always simplify your fractions. If you don't, I take off half a point. Negative 2 divided by 6. Well, I can simplify that by dividing top and bottom by 2, because that's a number they both have in common. So that gives me negative 1 over 3, which is the slope. But I'm going to show you the formula method too. Doesn't matter which one is x1, y1, and x2, y2. I'm just going to name the top and bottom. Here we go. Plugging it into our formula, y2 is negative 1, put that in glasses, minus y1 is positive 1, that's in glasses, over my x2 is 3, glasses, minus y1 is negative 3. This is why glasses help. It keeps track of these negatives. So now I'm at negative 1 minus 1, getting more negative is negative 2, over 3 minus negative 3. Well, right here, these two turn to positive, so I'm adding. So it's really 3 plus 3, which is 6. Don't stop. You have to simplify. Again, I'm dividing top and bottom by 2 because that's the number they have in common. Negative 2 divided by 2 is negative 1, over 6 divided by 2 is 3. Same slope regardless. Question 5. It says, what is the slope of a line that is perpendicular to the line in exercise 3? So that's here. First of all, if I have a perpendicular line, that means that, first of all, the lines cross each other and they intersect at a right angle. When we're talking about the slope of our perpendicular line has to be the opposite, which means different signs, positive and negative. Reciprocal. Oops, I'm spelling that wrong. That means a flipped upside down fraction. And the slope to begin with in exercise 3 was 4 over 5. So this is the original. To get to our new slope of our perpendicular line, remember this is our symbol. It looks like a right angle symbol for perpendicular. It means opposite, so different signs. Right now 4 over 5 is positive, the opposite is negative. Flipping, or the reciprocal, is flipping 4 over 5 upside down to be 5 over 4. That is your new slope. It's the opposite, different signs, and reciprocal is flipped upside down. Moving on. Whoopsies, wrong button. Question 6 and 7. You did not need to graph. You just had to tell me what's your slope and what's your y-intercept based off of these equations. So I'm going to start by saying slope equals y-intercept equals for both the problems. In these equations, both 6 and 7, they're actually in the form of slope-intercept form, where y equals mx plus b. M equals the slope, and b equals your y-intercept. So slope's always before your x. I'm going to look at question 6. We have y equals negative 4x minus 6. The m, or my slope, is before x, which is negative 4. My y-intercept is always after the x, which is minus 6. 7, same fashion. Looking for my slope, that is before my x, so that is the number 1/2. So my slope is 1/2. My y-intercept is always after the x, and that is negative 1/3. There's no work to do besides identifying from the equation. No graphing necessary. Oops, keep pushing the wrong button. Okay, questions I think I missed. Oh, did I miss some questions? I did miss some questions. That's okay. Okay, guys, here we go. So, I think those are the wrong problems. Whoops. Okay, that looks better. 8 and 9 is what we're trying to work on now. Both the directions are the same. We have to find the x and y intercepts. Remember, to find the x-intercept, you plug in 0 for y. To find your y-intercept, you plug in 0 for x. So you're plugging in 0 for the opposite variable. So a lot of people make some mistakes on that. So first I'm going to label my work here at the x-intercept, and I'm going to find the y-intercept. Okay, let's find the x-intercept first. So I'm going to be plugging in 0 for y. So starting with the equation, 3x minus 4y equals 24. I'm going to substitute or replace my y with 0. So I'm going to have 3x minus 4 times 0 equals 24. Anything times 0 is always 0. So I have 3x minus 0 equals 24. 3x minus 0 is 3x equals 24. To get my x by itself, I'm undoing the secret operation of multiplication with division. And then on this one, it tells me 24 divided by 3. That is 8. My x-intercept is 8. Y-intercept. So I'm going to start by writing the equation. 3x minus 4y equals 24. But this time, to find the y-intercept, I plug in 0 for x. So I'm going to have 3 times 0 minus 4y equals 24. Anything times 0 is 0 minus 4y equals 24. 0 minus 4y is negative 4y equals 24. Undoing the secret operation of multiplication here to get y by itself. Divide by the entire number in front of y, not just 4, but negative 4. This tells me my y-intercept is, well, positive divided by negative is negative. 24 divided by 4 is 6. Y-intercept is negative 6. Okay, moving on to question 9. Same idea. I have the x-intercept I have to find, and the y-intercept I have to find. Start by rewriting my problem. I have negative 6x plus 3y equals 12. Negative 6x plus 3y equals 12. Find the x-intercept. Says plug in 0 for y. Alright, that's what I'll do. So I'm going to get negative 6x plus 3 times 0 equals 12. Anything times 0 is 0. So I have negative 6x plus 0 equals 12. Negative 6x plus 0 is negative 6x equals 12. To get my x by itself, I'm undoing that secret operation of multiplication with division. Again, dividing by the entire number, not just 6, but negative 6, guys. This simplifies down to tell me my x-intercept. Well, positive divided by a negative is a negative. 12 divided by 6 is 2. So a lot of you say that was 6. We're not subtracting. We're dividing. Dividing, guys. Finding the y-intercept for problem 9. Said we had to plug in 0 for x. So, alright, I'll do that. That means negative 6 times 0 plus 3y equals 12. Negative 6 times 0 is 0. Plus 3y equals 12. 0 plus 3y is just 3y equals 12. Getting my y by itself, I'm doing secret operation of multiplication with division. Can divide both sides by 3. Positive divided by positive is positive, and 12 divided by 3 is 4. Those are your answers. Okay, almost done. So, question 10. It says it costs $2.50 to rent a pair of bowling shoes. So I'm going to start here. I have some money. I'm going to put a box around that. That sounds like it's going to be important. Bowling shoes. Well, I don't know much about those, but that sounds like important. I'll underline it. And it's going to cost $1.25 for each game bowled. Well, I don't know how many games I'm bowling yet. Here it says, write a linear equation that models the cost y of bowling x games. And we're going to graph the equation. Okay, we'll write a linear equation that models cost. So these two go together, total cost, and how many games I'm actually bowling. Well, looking at our bowling shoes to begin with, I am not buying multiple pairs of bowling shoes, or excuse me, renting multiple pairs of bowling shoes. That is a one-time fee. So I'm going to start by kind of starting with y equals mx plus b here. Y is my cost, x are the games. So y equals, well, let's see, m is our slope. M is related to my x, where x are the games. Let's see, what did it tell me about games? It said for each game bowled, it's going to cost me $1.75. I don't know how many games I'm going to bowl. That's why that's represented with the letter x. And because it's costing me $1.25 each game, that means that's my rate. That's my rate of change. So my m is $1.75 or 1.75 x plus the one-time fee of my bowling shoes. I am not buying or renting multiple bowling shoes. So here is my equation. Equation is y equals 1.75x plus $2.50. To graph it now, our scale here, which I told you in class, the x's just go by ones. So I have 1, 2, 3, 4, 5, 6, and 7. And I told you to go by 2's in class. So I have 2 for your y's. 2, 4, 6, 8, 10, 12, got a little small, 14. You're just estimating. This is going to be a rough sketch. It's not going to be perfect. But you can just pick a couple points to plug in. So let's see, this right here is 0. If I plug in 0 for my formula, that's 1.5 or 1.75x times 0, which is 0, plus 250. So my 250 is kind of right here. You know, give or take a few there. When I plug in, if I just pick 1, let's plug in a 1 to my equation. That would say y equals 1.75 times 1 plus $2.50. Well, 1.75 times 1, well, that's just 1.75 plus $2.50. This comes out to be $4.25 or 4.25. So at my x value of 1, my y, or the total cost, is $4.25. It's a little bit above my 4, kind of right there. Well, let's just pick another one. Let's just pick 2. Let's plug in an x value of 2. Y equals 1.75 times 2 plus 250. When you do 1.75 times 2, that's 350, or 3.5 if you'd like to think of it that way, plus 250. That gives me a nice number. That gives me 6, or 6.00 if you want to talk about money. So with my x value of 2, my y value is perfect. It is 6. No estimating there. Well, that's a pretty good line. I think I have enough information. I can just connect my points. It's not going to be perfect. But notice my line is not going to go all the way past here, because we're not going to talk about a negative number of games that we are playing. Oops, I did my line backwards. That's okay. I can fix that. So roughly, it kind of looks like that. That is what our line should look like. It's not a perfect graph, but it does give you a rough sketch, which is all I'm looking for. Okay, last one, number 11. This says you spend $50 on a meal for you and your friends. Oh, that's nice of you to pay for your friends. Part A. It says graph this equation 1.5y plus 4x equals 50. X is the number of sandwiches. Y is the number of beverages. Part B, we're going to interpret. We'll come back to that. Just like in class, I told you to scale your x's by 1. So 1, 2, 3, 4, 5, 6, 7. And then I told you to actually go up by 5s on your y. So 5, 10, 15, 20, 25, 30, 35. Well, this equation, to graph it, I don't want to move that to y equals mx plus b. That's going to be a lot of work. And I'm probably making some division mistakes. I don't want to do that. This is in standard form. So when I'm working on my standard form, I like to say the easiest thing is find your intercepts and just plot those 2 points. So that's what I'm going to do. I have a little column here for my x-intercept, and then I have a column for my y-intercept. To find my x-intercept, I plug in 0 for my my y here. So I'm going to start the equation. 1.5y plus 4x equals 50. Plugging in 0 for y, because I'm finding the x, I have 1.5 times 0 plus 4x equals 50. Anything times 0 is 0, plus 4x equals 50. 0 plus 4x, that's just 4x, equals 50. And then we're just going to do some division. It's not going to come out perfect, but that's okay. So I'm undoing secret operation of multiplication with some division. This tells me my x-intercept is actually 12.5. So I'll graph that shortly here. Here, my y-intercept. So again, start with my equation. 1.5y plus 4x equals 50. Finding the y-intercepts means you plug in 0 for x. So I have 1.5y plus 4 times 0 equals 50. Well, 4 times 0, or for anything times 0 is 0. So I have 1.5y plus 0 equals 50. 1.5 plus 0 is 1.5y plus 0 is 1.5y, which equals 50. We have to undo that secret operation of multiplication. To undo that division, we're going to divide both sides by 1.5. Again, this isn't going to come out perfect. It's going to be a rough estimate here. 50 divided by 1.5 gives you about 33.33 repeating. This is also the same thing. I'd hate mixed numbers, but you could write this as 33 and 1/3. Doing your decimal division, set that up for you. 50 goes in your house. 1.5 goes outside. You can't have decimals outside, so you have to move it. When you move it, you have to fill in a placeholder in your house. So really you're doing the division problem, 500 divided by 15. And then again, that's not going to work out perfectly. You will get 33 and about 1/3 left over. It's just going to constantly repeat. But here I was going to say or 33 1/3. I'm going to plot these points. That was the whole point. Was we're just going to do a rough estimate here and plot some points. So my y-intercept was 33.33. So that's about there. Our x-intercept, that x-intercept says it's 12.5. Well, it's like way out here. It's way out here. So I'm just going to estimate it's probably something like there. If I extended my graph. I really don't like to extend my graph, but we'll estimate that that's about 12.5. To make my line a little bit nicer, I can actually plug in some numbers like I did before. So let's just plug in 3 into our equation just to get another y value in here. So I'm going to have 1.5y plus 4 times 3 equals 50. The reason I'm doing this is just because I had to extend my graph to get my my x-intercept, and I don't really like to do that because I might mess up that spacing. So I'm just chose another x value just to plug into my equation and find a y. So that gives me 1.5y plus 4 times 3, that's the x value I chose, is 12, equals 50. I'm trying to solve for my y. Okay, so we're trying to get our y by itself, so we're subtracting 12 from both sides. I'm going to scoot over here for some more space. When I do 50 minus 12, that just gives me 38. And I'm left with 1.5y on the left. Getting y by itself, I'm undoing secret operation of multiplication. And when you do 38 divided by 1.5, again, it's not going to be perfect. These aren't nice numbers. That's real life for you. Y is about, remember 2 little squiggles, kind of looks like an equal sign is the word about in math. It's about 25.3. Technically, it's 0.33 repeating. I'm just going to estimate. That just gives me a nice little value here to get another point here on my graph. Let me turn to purple. So at x is 3, I have about 25.33 repeating. I'm just going to stop there and do my best to draw my points. See if I can draw my line right. Woo! Miss Horner did it. Here, it's actually going to stop at this x-intercept because then we're not going to talk about a negative number of beverages. That sounds ridiculous in real life. So it's actually just a straight line right here. It needs to just be a rough sketch, nothing fancy. B, this says interpret the intercepts. Okay, well at least I know what those are. So here I found my intercepts. I know that my x-intercept is 12.5. My y-intercept is about 33.3. To interpret, that means you are explaining in words what this means. To do that, you have to look at what the variables represent. X is the number of sandwiches. Well, the x-intercept means I plugged in 0. Well, 0 for my y means I didn't buy any beverages. So when I say interpret, it means explain. So explain what my x-intercept is. I'm going to say part B. My x-intercept means I could buy about, I'm going to round down. I could buy about 12 sandwiches without buying beverages. So buying no beverages, I could buy about 12 sandwiches. I'm not rounding up to 13 because that would mean I have more money than I actually do. Buying 12.5 sandwiches isn't really realistic, but I could buy 12. I have enough money for at least 12. That's why I rounded down. But to interpret just means if I didn't buy any beverages, I could buy this max number of sandwiches. Vice versa for my y-intercept, I could actually buy about, and again I'm going to round down, can't round up because that would mean you have more money than you actually do. We're going to say we're going to buy about 33 beverages without buying sandwiches. So if I bought no sandwiches, I could get about 33 drinks. That's what it means by interpret. Give some real life meaning to it. If there are problems on this quiz that you're still struggling with, please come see me in 7th period. I will help you out, especially with those word problems. Otherwise, have a good day. Bye, guys.